Today we're going to talk about 6.5 graphs and of both square and cube roots. So as you're copying down the notes here, if you don't do the first one, it's kind of up to you whether you do the first one or not, because I'm going to first talk about stuff we already know. We're going to graph y equals x to the third. I'm going to do this one fast because we've done this a lot. We just did it over here. We have the points. We choose our x values, 5x values, -2, -1, 0, 1. My y values would be -8, -1, 0, 1, and 8. So if I plot those points, it looks something like that. So we've done that quite a bit. We should be getting pretty comfortable with that. What would be the domain of that function? Domain is x values. Are there any x values that would not work? Any real numbers that I couldn't find, take that number to the third power and get a y value? They all work, don't they? So that means my domain would be all real numbers. There's nothing that doesn't work. Okay? Now the range is the y values. If I choose my x carefully, is there any y value that I wouldn't be able to get? No. So the range is also all real numbers. So today when you're making your graphs, it's going to ask you about domain and range. So we'll talk about that on all of these. Now, in graphing the cube roots, if you don't already have y equals x to the third, the trick is going to be choosing which x values you want to use, because when you look at this, let's see, we can just switch this, right? Because this is an inverse. So instead of -2, -8, I have -8, -2, -1, -1, 0, 0, 1, 1, 8, 2. We talked about doing that because you. But let's say I didn't have that y equals x to the third on the side. Then what you would think about is I want to think of an x value. When I take its cube root, I get a nice integer. So -8 is a perfect cube. So I would choose -8. -1 is a perfect cube, so I'd choose -1. So choosing your x values is going to be choose something that's going to make life easy for yourself. That's what it's all about. Okay, so we're going to plot those points. 0, 0, 1, 1, -1, -1, -2, -8, -2. And there's my graph of y equals the cube root of x. And I look at the domain of that. Is there any x value that doesn't work? No. Any y value that doesn't work? So my domain and range would again be all real numbers. So the cube and the cube roots are kind of nice that way. My domain and range, they always work. So they're all real numbers. So let's look at one where it's not quite, because you know you're not going to just graph the cube root of x 16 times, right? Or whatever, however many problems we got. So we're going to play with them a little bit. So I've got y equals 3 times the cube root of x plus 1. We know what our parent function looks like. Let's ignore the 3 out front for a minute. What does this plus 1 here by the x do to change the graph? What does it change? It moves it where? Up, down, left, or right? It's going to be to the right. Okay, if it was outside of the square root sign, then it would be up or down. We don't have anything there, so it's not going to move up or down. If it's inside the square root sign, then it's always opposite what you think it should be. Okay? So here's the way I always think about those. If there's nothing plus out here, I know my y value's got to be 0 at that middle point. And so I say, okay, what would I have to pick x to be to make that 0, well, I have to be negative 1. So I've got the point negative 1, 0. And that's going to be that center part of that parent function. It moved. What's the 3 going to do to it, guys? It's going to stretch it. It's going to be a pretty good stretch. Okay. So let's pick some values. Now here's where it gets a little bit tricky. I want to pick a number that I can put in for x that gives me negative 1, because I know negative 1 is a perfect cube. So what value would I choose for x? Negative 2. So then I say 3 times the cube root of negative 2 plus 1. So 3 times the cube root of negative 1 is going to be negative 3. Okay? So let's go the other direction. What would I choose x to be if I wanted this all to be 1 under here? 0. Okay, so if I made this 0, 3, the cube root of 0 plus 1, that's just going to be 3. Okay, so now the next one, I want that to be negative 8. What would I choose x to be? Negative 9. So I'd have 3 times the cube root of negative 9 plus 1, 3 times the cube root of negative 8, 3 times negative 2 gives me negative 6. So I would have negative 9, negative 6. Okay? I have one more. So I want that to be a positive 8. 7. Okay, 7 plus 1 is 8. 3 times the cube root of 8. 3 times 2, which gives me 6. Okay, I'm going to erase my scratch mark here. Okay, so let's plot our points here. So I've got the point, negative 1, 0. So it didn't move right, it moved left, didn't it? I lied to you. Okay, and then negative 2, negative 3, and negative 9, negative 6, 4, 5, 6, and then 0, 3, and 4, 5, 6, 7, 1, 2, 3, 4, 5, 6. And there's my cube root. So it's stretched out this way and shifted to the left one. Now, domain and range, that didn't change, right? That's still all real numbers. That's what we're going to do for today. Now, that's the cube roots. We haven't done the square roots yet. Okay. So, let's look at square roots. So to look at square roots, let's first look at y equals x squared. You guys are very familiar with the graph of a y equals x squared. I think I even need to talk about it much. That's that nice parabola, symmetric, does all sorts of pretty things. What's the domain of that function? Y is greater than 0 is going to be which one? Range. So range is the y is greater than 0. So the littlest y can be is 0. Domain's all real numbers. There's no x's that can't go in. Okay? Okay, so we're starting to get into some things here now. I want to graph y equals the square root of x. Well, let's see what happens when I just switch the numbers. Do the numbers in my table match my equation? Now, what could you tell me about my x values first? Can I ever get a negative x value here? So my domain is going to have to be x greater than or equal to 0. Because when I take the square root of a negative number, I get an I, and we're not going to try and graph i's in the coordinate plane. It doesn't work. There's a complex plane, but, you know, that's a whole other thing. Okay. You'll notice y equals, this is the positive square root of x. There's no plus or minus out front here. So this is really only half of the parabola. This is going to be 0, 0, 1, 1, 4, 2. It's just this out. Now, you could graph y equals a negative square root of x. And that would also be a function, but there's going to be two different functions. So for the one I have here, and this is our parent function, we're going to have y greater than or equal to 0. So the way it's drawn, is this an inverse of the other one? It isn't. In order to make this be the inverse of what I have here, what do I have to do? I have to restrict my domain. Okay? If I restricted the domain so that x is greater than or equal to 0, then I would have just this half of the parabola, and this would be its inverse. Okay? So without a restriction, the inverse of the parabola is not a function, and we want all of these ones to be functions. So for what you're going to be doing today, we're only going to graph using 3 points when you graph a square root, because we're only going to do half of that parabola. We're not going to do the two sides. Okay, so let's try one that's more interesting than this one. So there's our parent graph right here. So let's look at a more interesting one. We're going to graph y equals negative 2 times the square root of x minus 3 plus 2. How is this one going to shift? Up 2. It's negative 3, so we're going to go right 3. So my vertex is going to be the point 3, 2. Okay, so that's your starting point. That's how you pick your first point. Okay, it was here. And you want to make that 0, so you pick 3 minus 3 is 0. And then this gives you your y value. Okay. What's the negative 2 going to do for this before we start doing points? It's going to be the bottom half of the parabola, and the 2 is going to make it stretch. It's going to make it bigger. Okay. So let's see. We need to choose an x value that makes everything under here equal to 1, because 1's a perfect square. So what would x be? 4? 4 minus 3 is 1? Okay, so let's pick 4, because then I get negative 2, square root of 4 minus 3, plus 2 is negative 2, square root of 1, plus 2, 0. Okay? What's my next perfect square after 1? That's cube. 1 squared is 1, 2 squared is 4. So we want to make this equal to 4. What's my x got to be? 7. So when I say negative 2 times the square root of 7 minus 3 plus 2, negative 2 square root of 4 plus 2, negative 2 times 2 plus 2 is negative that's kind of what we predicted it was gonna be. Now, domain. X, what's the lowest value X can have? The lowest value X can have is 3, right? And then I can choose any value bigger than 3. So I would say for the domain that X is greater than or equal to 3. Now the range. Think about this. Y values. Y is always up and down, right? So what's the highest Y can be? Can be 2, and then it's going to go down from there. So Y for the range will be less than or equal to 2. So that's what they're going to look like today. Any questions? Okay. Then I will hand these out.